Hello, in this video we're going to prove the number e is irrational. So first, let's think about what irrational means. Irrational means the number is not rational. And since we are trying to prove negatives, so this means it is not rational. And since we are trying to prove negatives, it would be best to use proof by contradiction. So we're going to assume that e is rational and we're going to get a contradiction. So here is the solution. On the contrary, assume e is rational. So if it is rational, then it can be written as a over b for some integers a and b. Now, we are going to write down the power series for e to the power of x, the Taylor series for e to the power of x, and we'll go from there. So we know that e to the power of x is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus ... Now we're going to substitute by x by 1. So x equals 1 gives us e equals 1 plus 1 over 1 factorial, 1 over 2 factorial, etc. Now I'm going to substitute e by a over b, and we'll see how we can get a contradiction. We're going to clear the denominator. Since I want to clear a lot of the denominators, I'm going to multiply both sides by b factorial rather than b. So you get ab factorial over b equals b factorial plus b factorial over 1 factorial, b factorial over 2 factorial. Anywhere between 0 factorial all the way to b factorial is gonna become an integer. The next term becomes b factorial over b plus 1 factorial. Next term is b factorial over b plus 2 factorial plus etc. Now we know that a b factorial over b is an integer, and b factorial over k factorial is also an integer for any k from 0 to b. So this portion is an integer. This portion is also an integer. It means the rest of it must be an integer. So thus b factorial over b plus 1 factorial plus b factorial over b plus 2 factorial, etc. is an integer. However, if you look at this expression, first it is positive. This is actually not too large. b factorial over b plus 2 factorial, etc. This is going to be 1 over b plus 1, because the b factorial in the numerator and denominator cancel. 1 over b plus 1 times b plus 2. The next term becomes 1 over b plus 1, b plus 2, b plus 3, plus etc. Now, I can't really evaluate this expression. However, what I can do is I can simplify this by replacing the denominators by powers of b plus 1. So the first denominator is b plus 1. The second denominator is larger than b plus 1 squared. So if I replace it by b plus 1 squared, then I would get 1 over b plus 1 squared. And the next term becomes b plus 1 cubed, etc. Now, anytime you're doing limits, if you have a sequence an less than a sequence bn, the limit becomes less than or equal to. So an less than bn implies the limit of an is less than or equal to the limit of bn as n approaches infinity. So it's best to turn these into inequalities less than or equal to. It is not false to say it is less than, but the justification needs a little bit more work. So we're going to just write it down this way. And if you evaluate this geometric sum, it is the first term divided by 1 minus common ratio, and that is 1 over b. So this number that is an integer is more than 0 and less than or equal to 1 over b. In order to say this is less than 1, we would have to make sure that b is more than 1. And that's not difficult to do, because since e is a rational number, we could assume that both numerator and denominator are more than 1. If they aren't, we just double them and the same thing would work. So this is a contradiction. Because we found some number, this quantity, that is an integer, but at the same time it is greater than 0 and less than 1, because there are no integers in between. In the interval, open interval 0 to 1. So this completes the solution for this problem. This is a very standard and interesting proof for the fact that E is irrational. Now, as an exercise, try this one. Try to show sine of 1 and cosine of 1 are irrational. And you would see that this is you can employ a similar idea. Okay, so this brings me to the end of this video. If you would like to see more of these types of videos and math competition type videos, feel free to subscribe, and I will see you in the next video.